Hello students, how are you all? Today's topic is liquid pressure. Yes, say you have taken a vessel. Fine, the vessel is containing a liquid, any liquid, say milk or kerosene or water. Do you know that liquid exerts pressure in all the direction? I mean on the wall of that vessel. Let me draw it. Say, this is the vessel I have taken. Fine. And this much is any liquid. Say water I have taken. Fine. Now, this water exerts pressure in all the direction of this wall, I mean wall of the vessel. This liquid, this water or milk, any liquid exerts pressure on this wall of the vessel in all the direction, everywhere, all the direction on the vessel. Fine. Now we will see what is the amount of that pressure. Fine. We will see that, say at any point of the liquid, say here at this point or at this point, what is the liquid pressure at that point? Say if the pressure is P here, then what is the value of P? Means how to find it mathematically. Let us discuss that. For this, I am taking a vessel. This is the vessel, right? And I am taking any liquid in it. Say this is the liquid. Fine. Now, I want to find the pressure, say at this point. Fine. At point A. Okay. I want to find pressure on that. Now, we have to consider a circle around this A. Fine. Say this is the circle I am considering. Okay. Now, to find the pressure at A, we know the formula of pressure. What is pressure? Pressure equal to force by area. So, same way, pressure equal to force by area. Fine. We'll be using this formula to find the pressure at this point. So first what we did, we took an area around that particular point for which you want to find the pressure. Now this is that circular area. Okay. Now from that circular area, I will draw two lines to the surface of that liquid. I mean this way. This way. Fine. So can you tell me what is this shape? Yes, it's a cylinder. Fine. So to find the pressure equal to force by area, we have to find how much force exerts by this cylinder first. Fine. To find the force exerted by this cylinder, I mean what is the weight of this cylinder? Yes, as I told you in the previous video, the link of that video is there in the description box. I told you that the force is weight. Like what is the force when you are standing on the earth's surface? If I am sitting on a chair, how much force I am giving to the chair? That is my weight. Okay. What is the amount of weight? That is the amount of force which I am giving to the earth's surface. Got it? So, what is the force exerted by this cylinder means the weight of this cylinder. Okay. So, Force means weight of the cylinder by area. Fine. Now, weight means mass into gravity. We know this formula. Mass into gravity by A. A means area. This area equal to. Mass means volume into density. Volume into density. Okay? Into gravity by area. Fine. Now, say this is the point I want to find the pressure of at this point. Now, as I told you that I have considered an area around it. Okay? So, what is this shape? Circular shape. Let us consider that the radius of that circular shape is R. That means this is R. Okay? And let us consider this height is H. So now you know the radius of this cylinder and also the height of the cylinder. So can you tell me what is the volume of that cylinder? What is the formula of volume? Pi r square h of a cylinder. So what is the volume of the cylinder? Pi r square h. So instead of volume, I can write pi r square h. So pi r square h into d into g by area. I mean this area. What is this area? As I told you, I want to find the pressure at which point? This point, A. At this point, I want to find the pressure. So, first what we did? We considered a circular area around it. Circular area I have taken. And R is the radius of that circle. So, what is the area of this circular portion? Pi r square. We know the formula of area is pi r square. Correct? So, we'll write pi r square. Fine. Now cancel pi, r square. So, h into d into g. This is the formula to find the pressure at any point of a liquid. Fine. So, h is height. I mean depth. Okay? Depth from the surface of that liquid. From the surface of the liquid, what is the depth at this point? This is h. D is density of this liquid. And g is gravity. So, what we discussed? We discussed that, say this is the vessel I have taken. Fine. And this is the level of that liquid surface. Now, if I want to find the pressure at this point, then pressure equal to HdG. What is H? H is this depth. So, H equal to depth. From here to this point, H. Then what is D? Density. What is G? Gravity. So, in this way, I can say that if I discuss the SI unit of all this, H is depth, it's meter. D, density. What is the unit of density? kg per meter cube. kg per meter cube. Gravity. What is the unit of gravity? Meter per second square. Yes. Meter per second square. All these units I have written in SI system. Don't forget. In SI system, depth is in meter, density is in kg per meter cube, and gravity is in meter per second square. Okay. So if you use all these values, then you will get the pressure in Pascal. Understood? Now one more information. What we discussed? We considered a vessel here, and this is the liquid surface. Okay, I want to find the pressure at this point. Fine. What is the pressure? First we have to measure the depth. Okay, H is the depth. So what is the pressure here? Pressure is equal to this depth H, then what is the density of this liquid? D, and what is the gravity? G. So HdG is the pressure at this point. But just see this figure. The liquid is also in contact with air. I mean atmosphere. How? Here. This is open surface of the liquid. So this portion is in touch with the air. So air is there. Air. That means air is also giving a pressure on this liquid. Yes. This is atmospheric pressure we called. Okay. This air, this liquid also in contact with this air, and this air is also giving a pressure on the liquid, which we call atmospheric pressure. And the symbol which we use for this is P naught. We call it P naught, not P0. We'll not call it P0. We'll call it P naught. So P naught is atmospheric pressure. The pressure exerts by air. Okay, atmospheric pressure. So at this point, what is the total pressure? The pressure exerts by liquid plus atmospheric pressure. Understood? So when you are finding the pressure at any point of liquid, I repeat, when you are finding the pressure at any point of liquid, then you have to use this formula HdG. H is the depth of that point from that liquid surface. D is the density of that liquid. G is gravity. And what is P naught? P naught also you have to use, because P naught is atmospheric pressure. Because your atmosphere is also giving pressure on liquid. Understood? So what is the total pressure at this point? Total pressure at this point is P, which is P naught, atmospheric pressure, HdG. And we know the unit. H is depth, meter, and D is density, kg per meter cube, and G is gravity, meter per second square. Okay, all these are unit. By using this unit, we got the unit of pressure is Pascal. And remember all these units I discussed in, yes, SI system. SI. Got it? Now we are ready to solve some numericals. Let's start. See the question which is displaying on your screen. At what depth below the surface of water will pressure be equal to twice the atmospheric pressure? You understood the question? See, say this is water surface. Fine, this is water. Now, they are asking me the depth, means the pressure here is twice the atmospheric pressure. From here the atmospheric pressure is coming. What is the symbol of atmospheric pressure? P naught. P naught. Okay. So according to the question, they said that here pressure is this pressure equal to twice the atmospheric pressure. Understood? This is P naught, atmospheric pressure. So according to the question, the pressure at this point is twice the atmospheric pressure. This is the equation we can develop from this question. Got it? Now, P is the pressure at this point. I taught you at this point pressure means the pressure exerts by liquid plus atmospheric pressure. So pressure exerts by liquid. What is the formula? HdG. H is this depth. So HdG plus atmospheric pressure. Yes, what is the pressure here? The pressure by liquid plus atmospheric pressure equal to twice of atmospheric pressure. Understood this line? We'll continue this. H is the depth which we need to calculate according to this question. D is the density of water. What is the density of water given in the question? 10 to the power 3 kg per meter cube. Okay? 10 to the power 3 means 1000. So 1000. What is gravity is given? Gravity is 10. So we are using 10 plus, not plus, we'll take this P0 over there. Fine. P0 if you are taking there, 2P0 minus P0. Fine. Now H into, fine. Now if you see the question, what is the atmospheric pressure given? 10 to the power 5. Yes. So atmospheric pressure, now P 2P naught minus P naught is P naught. Fine. So H into 10,000 is 10,000 H equal to, what is P naught? Atmospheric pressure. What is the value given in the question? 10 to the power 5. 10 to the power 5 means 1, 2, 3, 4, 5 zeros. So what is H? H equal to this one by this. Fine. 4 zeros cancel. So H equal to 10 meter. So what is the depth from the water surface? 10 meter. So 10 meter is the depth where the pressure is twice the atmospheric pressure. Understood? Let us move to our next question. Read the next question displaying on your screen. It's a big question. A cube is there, the cube of side 15 centimeter. Yes, the cube is completely immersed in water whose density is 10 to the power 3 kg per meter cube, and the top surface of the cube is at a depth of 20 centimeter. Understood the question? Let us draw it. This is water surface. Fine. 20 centimeter depth. This is 20 centimeter. At a depth of 20 centimeter, the cube is placed. This is the cube, whose side is 15 centimeter. Fine. Now, what do we have to find? The pressure at the top of the cube. I mean at this point, A, at the top of the cube. And number B, the pressure at the bottom of the cube. I mean here at B. So first of all, we have to find the pressure at A and then pressure at B. And remember, the cube is immersed in the water. See, this is water. The cube is immersed. This is the cube, which is immersed in the water, and we have to find the pressure at the top. I mean at A, and what is the pressure at B? That is bottom. Okay? So, first of all, we'll see what is the pressure at A. Pressure at A. We know the formula. Atmospheric pressure plus liquid pressure. Atmospheric pressure plus liquid pressure. Liquid pressure is HdG. Now, what is the atmospheric pressure? It's given in the question. 10 to the power 5 plus. Now, H is the depth. This is the depth. We are finding the pressure of A. So A means what is the depth? 20 centimeter. But this is given in centimeter. We have to convert it into meter because the whole sum we are doing in SI system. So 20 centimeter means 20 by 100. What is the density of water that's given in the question? 1000. 10 to the power 3000. 1000. What is gravity? 10. It's also given in the question. Now let us calculate it. 10 to the power 5 means, okay, plus this double zero cancelled. So what we are getting? 2,000. Fine. So what is the pressure? 102,000. This Pascal. Any doubt? This is the pressure at A. Now we'll find what is the pressure at B. So pressure at B. Same way, pressure equal to, we know that P naught plus P naught means atmospheric pressure. So here we are not writing formula, directly we are putting the values because formula is there. So P naught means 10 to the power 5 plus HDG. What is the depth at B? Can you tell me what is the depth at B? This 20 plus 15, 35 centimeter is the total depth of B. Total depth is 35 centimeter. How 35 centimeter? This is 20, this is 15. So total depth is 35 centimeter. Got it? So 35 by 100. Again we are converting into meter into 1000. That is the density of water into gravity 10. Now 10 to the power 5 means, okay, plus double zero. So 3500. That is 103500 Pascal. So we got the pressure at A and pressure at B. What is in question number C? Number C, the resultant pressure on cube. Yes, what is the resultant pressure on cube? The resultant pressure on cube, to find that, just we have to subtract these values. Okay, which is higher? Obviously this is higher. 103500. This is 102000. So this is higher. So just we need to subtract to find the resultant pressure. So what is the resultant pressure? Let us find it. The resultant pressure. The resultant pressure on the cube equal to, I told you, the higher pressure minus the lower pressure. What is the higher one? 103500 minus 102000. What we are getting? 0051. 1500 Pascal we are getting. That is the resultant pressure acting on this cube. Okay. Number D. Number D is, we have to find the resultant thrust. That is the complete force acting on the cube. Got it? The complete force. Thrust means force. The complete thrust means complete force acting on this cube. Same formula, pressure equal to force by area. Fine. For that, we know this formula, pressure equal to force by area. This force means thrust, which we are required to find here. Okay. So what is the pressure? What is the resultant pressure? Resultant pressure is 1500. 1500. What is the thrust? We need to find that. Force. What is the area? What is the area of the cube? What is the area of one surface? Only one surface we need to find. Fine. So what is the area of the cube? Area we know, the top surface or the bottom, any surface you have to find. What is the area? If you see the shape of the top or any face, a cube, this is the cube which is immersed here. Fine. So in the cube, if you see the cube, how many faces are there? Total 6 faces. Top, bottom, this side, this side, this side and this side. Total 6 faces. Only one face you have to take. What is the area of that face? This is square. Square. Whose all the sides are 15 centimeter. So what is the area of square? 15 into 15. That means area is 15 into 15. Fine. But these are in centimeter. We need to convert it into meter. So by 100 by 100. Fine. That is the area of one face of the cube. Now 15 15 225 by. Fine. Yeah. So what we are getting? 0.0225. Got it? Yes, 0.0225. This area will utilize here. So 0.0225. Now cross multiply it. So force equal to 1 into F. Now 1500 into this. 1500 into 0.0225. If you cancel this point, you are getting, yes, double zero cancelled. So 15 into 225, 3375, that is 15 into 225, 3375 by 100. That is, what is the force? 3375 by 100 means 33.75 Newton. This is the resultant thrust or resultant force exerts in that cube. Understood? So the sum is easy. Just you have to remember the technique. It's an important sum. So you have to know the formula and the way we need to solve the sum. I hope you understood. Thank you.